So the lead code problem we are going to solve now is called maximum area of islands, and we can see that this one is a medium problem and also a very well-liked problem. The statement is quite straightforward. We are given an m cross n binary matrix named grid. Now for this particular grid, we are given bunch of different ones and bunch of different zeros. Now we are being told that ones represents an island and zero represents just water. Okay, then we need to return the maximum area of an island that we can make inside the grid, and if there are no islands that we can form, we need to return 0. Plus we are being told that every single cell with value 1 is the island, and if there are bunch of different ones connected with each other, then we need to basically do the addition of all of those cells, and then we can consider them as one entire block of an island. So let's try to understand this with an example. Here is an m cross n grid we are given, and we can see that there are bunch of different zeros and bunch of different ones. Now some ones are isolated, so this is just an island in its own, and we can see that the area of this particular island is going to be value number 1 because it is only connected with just one island by itself. But if we take a look at some other islands, we can see that they actually form bunch of different ones that are adjacent to each other amongst all 4 horizontal values, and that increases the area of those particular islands. So we will have this island that is of size 4, same way this island of size 5, and so on and so forth. Now we need to return the island that contains the maximum value. So in this case, this island chain or this connection of ones are actually total area of 6. So in this case, we will need to return the maximum area of islands as 6 as the answer. So this is what we need to return. Now let's try to understand that what are the different logic we can take to solve this problem. Now we know it's a very straightforward problem. The idea is that we are going to iterate in one single direction from the starting point, and the moment we identify that there exists some island or value number 1, then we need to iterate over every single possible neighbor of this particular one. And the moment we exhaust all the possibilities by exploring every single neighbor, we can determine that that has been the current area that we have been able to find. Plus we will also need to keep track that what is the maximum island chain we have been able to identify it so far. So let's try to understand the most common basic approach to solve this problem. Let's say that we start iterating from this very first cell in sequence, in just regular sequence. So we say that this is water, this is water, so there is no area we can find. We come to this node, this value is 1. So the moment we identify 1, we will have to take a look in all 4 directions to see if there are any possible island chains that we can make. Since in this case there are no island chains we can form, we can say that the area of the current value we have been able to identify so far is 1, and so far we have only found one island with area 1, so the maximum area we found so far is also 1. After doing this, we will have to mark this one as being visited because we have already visited this node. And why are we marking it visited? I'll just explain it to you later. So let's say that we mark this one as visited as well. Okay, that this one has already been taken care of. We iterate again, nothing, we don't find anything. Once again we find one more one over here, which means we will have to do the iteration for our current updation right now. So once again we start looking in all 4 directions. The moment we go to this direction, we find one more one. So once again for this particular one, we will have to repeat the same operation, look in all 4 directions. And here the problem may arise. Let's say that we look in this direction and this direction, and then we decide to look up into this direction. So this is also a neighbor of 1, and we can also by mistakenly calculate this one once again, so as part of the island, which means we may stay inside an infinite loop. And that's why, in order to prevent that issue, the moment any particular value that we have visited, we are just going to mark that that value has been visited, so we don't recount those values again. So let's say that we count this value, then we go into this direction, and so far we have visited all of these 4 ones, and the current area so far we found is 4, which means maximum area also needs to be updated. So we are going to update the maximum area once again. Now we start our iteration in the similar fashion. These are all zeros, so nothing to do with this. Once again, this one would have been 1, but since we already visited this one, there is no point in redoing the same operation. So we are just going to go and ignore this case completely, and once again we are going to ignore all of these cases. Once again we identified 1 1, so far the area is going to be 4. We cancel out all of these 4 nodes as well, and we keep on repeating the same operation until we find the maximum area, which we would find when we get to this particular one as value number 6, and this is what we need to return in this case. So the moment I was explaining this solution, it should completely come to your head that this is actually a graph problem, where this given m cross n grid is actually the matrix we are given that represents a graph. It's an adjacency matrix, and for this adjacency matrix, all we need to do is we will have to find that what are all the connected components for any particular graph, and the cluster of the connected components, whichever has the highest value, we simply need to return that as part of the answer, or as part of the area we have been able to calculate so far. Now we know with any particular graph problem, the most important thing is that how we are going to iterate over the graph. So we know that iterating over an m cross n grid is quite straightforward. We simply need to run 2 for loops to iterate over that. The moment we identify any particular one, then we will have to explore in all 4 directions and iterate over the entire set of directions where whichever the value is 1, and we will have to keep on repeating the same operation. So logically, all we are doing is a depth first search whenever we identify any particular one that exists. We can also do a BFS, but DFS in my opinion would make much more sense in this case, because we need to go in any particular direction. It won't change the result, but I just like to use DFS for this particular type of case. Then in order to complete the DFS and not run into the issue of recounting the same value, we will have to keep track of all the visited nodes. For that, we have 2 options. One option is that we can try to manipulate the existing input, but let's say that your interviewer is very picky and he or she does not want you to play around with originally given input. So instead of playing around with originally given input, you can also create a m cross n matrix and just mark all the values by 0, whichever the ones that you have visited so far. So that way also you can just keep track of all the nodes that you have visited, and you are only going to do a DFS on unvisited nodes. So that's it. That is the whole solution. And on top of it, for the entire duration, you are going to keep track of the current area that you have found so far, and the maximum area that you have been able to find so far. And combination of this would actually solve this problem quite simply, quite easily. Let's try to understand the time and space complexity in this case. Time complexity is simply going to be big O of m cross n, because we will have to iterate over every single cell, and even for our DFS operation, we are going to mark those nodes as visited. In terms of space complexity, because we are using an extra space to store all the visited nodes, it is also going to be big O of m multiplied by n, or nodes multiplied by edges. So in this case, overall this is a very good time and space complexity. Once you understand that this one is actually a graph problem, it becomes very simple to solve and also move forward. So now let's quickly see the coding solution for this one. So the coding solution is quite straightforward. We are given our max area of island that we need to find, and we are given the grid as part of the input. First thing we are going to do is to check that if the given grid is equal to null, then we are simply going to return 0. It's an edge case. Then we are going to initialize a variable called max area, and initially the value is going to be 0. Then we are going to iterate over every single value that is currently present inside our grid using 2 loops, I and j. And for every single value, first thing we are going to check is that if the given grid position, if that is equal to 1, then we will start calculating the area of this current one that we have been able to identify so far, and we will have to iterate over in all 4 directions, and that's where we are using the DFS method. Next thing, for every single one that we have been able to identify so far, it could be possible that that particular value could be the maximum area we have been able to identify so far. So we are going to compare the maximum area we have so far and the new area or the current area we just found for this particular through this DFS call. Now let's understand this DFS call and how does it work. In the input, we are providing the grid that we are working with. we are also providing the current I and jth position. Very first thing we are checking is that if the given grid is going out of bounds in either one of these cases, we are simply going to return 0. Or if the given grid position I and j that we are working with, if that is also 0, then also we can return 0. If that is not the case, we are going to mark this cell as visited. Now in this case, I'm not using an extra hash set. I'm just using the same grid to update the call. But if your interviewer asks you that you cannot change the given input, then you might need to create a new instance of a new m cross n matrix and repeat the same operation. Then we are going to add value of area by 1, and then we are going to make 4 different calls in all 4 directions, and we are going to do the plus and equal to operation for the area, which means for every single one that we are being able to identify in each of these 4 areas, we are going to add that value to our existing area, and we are simply returning the area in the end. So this is our helper method, where recursively we are using the DFS operation, and we are updating the area of the current area we have been able to identify it so far. In the end, we simply need to return the max area we have been able to identify so far once this for loop call ends. So now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which is exceptionally good. So once again, the solution is present in our GitHub repository, so feel free to go ahead and check it out. Thank you.